Okay, welcome back. We're going to go ahead and get started. This is Tuesday, February 18th, 2020. This is the lesson referring to factoring out a GCF. And first I'm going to write this, but then I'm going to erase it. I want to tell you all what a GCF is. It stands for a greatest common factor, where a factor is just some number that multiplies to give you another number. So if we go to number 1, and I'll do the odds and I'll expect you to do the evens for homework. If we have number 1, it says 16p to the 4th plus 4p to the 3rd. I'm going to write a little bit more in this first example than I probably will in the future ones, but here's kind of the idea. So if we take 16p4, and I think of the factors of 16, I got 1 and 16, whoops, 4 times 4, 2 times 8, and then I got to do also the factors of 4, which would be 1 and 4, 2 and 2. So if we look at both of these lists, the greatest common factor, which would be the factor that both of them have, would be 4. 16 is obviously bigger than all of these numbers, but there's not a 16 over here, which is why 16 is not the greatest common factor. You'll also notice they have a factor of 2 and 1 in common, but again, those are not the greatest, 4 being bigger than both of those. So to start off this problem with 4 would be a nudge in the number direction. Now if we focus on the variables, so the common factor between two variables is always going to be the lowest degree. So by that, let's look at that similar to the way that we looked at the 16 and the 4. P4 and P3. And if we look at what they have in common, they both have 3, which is the lower exponent. So to finish this greatest common factor, just like normal factoring, we're going to basically be doing multiplication in reverse. So the greatest common factor will always appear to the left, and then whatever you need to multiply on the inside of the brackets to get our original problem is what we're now looking for. So I try to think, what times 4, so a number here and a number here, just like when we factor, what number times 4 also gives me 16? Well, that would be 4 times 4. Distribute, 4 times 4 is 16. P to the 3rd would be 1 short of P to the 4th, so we'll need a P here. Now when I distribute, 4 times 4 is 16, P3 and P1 is going to be P4. Then I just move on to the next term. So now I just think, okay, 4 times what gives me 4? That would be 1. And then P3 to become P3 would just stay the same. So if I multiply that by 1, that will stay the same. And there's your answer. Let's try another one. Number 3. Okay, before I get too far into number 3, first thing I don't like about it, it's not in standard form. So before we factor, let's make sure we have our numbers in the correct order, in descending order. And now I can figure out what are the common factors between 45 and 63. And then do 63. Now sometimes these are going to jump out at you. You don't have to make this list every single time, but sometimes it helps. 3, 4, 5, 6, 7, and 9. Let's see, I'm going to go ahead and stop and say that 9 is the greatest common factor between these two. And then when you get to the variable part, this one has a b and this one doesn't. So they don't share a value of a variable. So open that up, and then what do I have to multiply here and here to get 63 and 45b? Answer would be 9 times 5b gives me that. And 9 times, well, look over here, 7. Now something I kind of went a little quick over last time was our sign. We put a plus sign there, and that's because 4 times 1 gives us positive 4. So be careful of your sign. If there is a negative involved, make sure you take that into account. In this case, it's also a positive, so 9 positive times 7 also positive will give us positive 63. And there's your answer. Let's look at number 5. Okay, this isn't going to happen too terribly often, but anytime there's a negative in the front, go ahead and take out a negative GCF. So I'm going to open up my parentheses, and I know whatever I take out is going to be a negative. Now, if you look at the two lists of factors between 6 and 6, 2 and 3, 1 and 6, well, this is going to be the same list, right? So the biggest number in that list is 6, and then the lowest degree variable. Let me back this up just a little bit. 6r to the 4th. Lowest degree variable is what they will share. So when I think of what I got to multiply in here to get negative 6r to the 5th, I'll have to multiply a positive 1. Negative times a positive is a negative. And then I need one additional r. R4, R1 gives me R5. And then the last part, if you'll notice that we've actually got the identical GCF in second term. So if I want this to stay the same, what do I need to multiply by? Hopefully you said 1. And there's your answer. Okay, let's look at 2 or 3 more of these. I will say this as we get to the halfway mark, that these problems are much different than your typical factor problems. That's what this week will pretty much entail, our challenging factoring problems or weird looking type of factor problems. Okay, so back to number 7. We have 3 terms now. 3 terms if you count them 1, 2, 3. And so nothing really changes except for I have to think of now the greatest common factor between 14 and 21 and 21. And I'll tell you what, this is actually going to be kind of an easier example since these two match. Let's see if you can first write this in standard form. Go ahead and pause the video. Take a second. If you paused it, we're done. Now we're back, and the standard form of this should be always putting big, little, littlest when talking about degree. And then the GCF between these 3 pieces, well, if you look at the A's, let's do that first. We've been doing the number first. Let's do the variable first. The lowest degree here is 1, so they all share 1A. And then between the 2 lists of 21 and 14, I could do 2 lists of 21 and then a third list of 14, I guess, but it's kind of tedious as these 2 lists will stay the same. The GCF is 7. And then it's just a thought process of, I want to get rid of this part, make sure we're looking at the right one. What do I have to multiply 7 by to get 21? That's 3. What do I have to multiply A by to get A3? That's A2. 1 here, 2 here, 3 here. Go to the next part. 7 times, again, 3 gives us 21. There's 1A here. I need an additional A to have 2. And the last part, 7 times 2 is 14. And I already have an A, so I don't need an additional A. That's where I'll stop. So your answer here is GCF is 7A. Choose to write the 1 exponent or not. That is up to you. And then the inside is 3A squared plus 3A plus 2. All right, let's see if you can remember on number 9 now what I said if there was a negative at the start. If there is a negative, go ahead and just take that out. So I know I'm going to take out a negative. As far as the V's go, if you notice here, there's 2 here, 1 here, and none here. So between all 3 of these, they actually don't share anything as far as variables go. These 2 do, but because of this guy, we're going to have to ignore those. So not all of those have a V, so let's just think about the numbers here. 28, let's see if I can change color here, make it a little bit more easy to read. 28, 8, and 36. Let's see, that's 2 and 14, that's 2 and 4, that's 2 and 18. Let's see if we can go further. 3 and 12, 4 and 9, 1 and 8, 1 and 28, 4 and I'm going to go with 4. Hopefully you saw that. And that would leave me with, okay, now be careful here. Negative times a positive is going to result in negative 28. Well, phooey. Let's see, and then the next one is a negative and a positive will result in a negative, and I need 2. Again, that's coming from 4 times 2 right here. And the last part would be 4 times, we said 9 would be 36. Okay. Let's try number 11. First, I'm going to write it in standard form, and I'd like you to try it on your own. If you would, please pause the video so you can see if you can truly do this one on your own. And as I'm looking at this example, I want to look at instead number 13. Number 13, go ahead and pause the video. It's already in standard form. Factor out the GCF, and then hit play. All right, we're looking at the answer to number 13. You should have taken out a negative 3k, lowest degree is 1. And then to get back to our original, we would have to multiply negative 3 times 1 to get negative 3. We need an additional 2k's. Negative 3 times negative 5 is positive 15k, and we need an additional k there. And lastly, negative 3 times positive 2 is going to be negative 6. And then there's a k, there's a k. We do not need to add in anymore. There's your answer. Okay, how many more do we have here? Tell you what, I'll do a couple more, but I think I'm going to go ahead and stop with the audio. If you want to watch the solutions and then try the evens, that's fine. You do not have to have the last 3 finished when you turn in the assignment. If you want to stop the video, rewind the video, and start your homework now, that's totally up to you.